The goal of using any mathematical model in biology, whether we're talking about phylogenetics or anything else, is to try and capture the important features of the data we've observed using relatively simple mathematical principles. The models we're assuming aren't going to be able to capture every detail of the processes that have generated our data, but they should capture the important features in a way that allows us to test and compare hypotheses. And that's why it's important to perform absolute model fit checking in addition to just model selection. It could be that all the available models that we have make some assumptions in common, and if these assumptions violate important aspects of the data generating process, the conclusions we draw could be biased or we could be misled. And so we want to have ways of checking our model against our data to ensure that we're on solid footing, that the conclusions we're drawing are reasonable and valid. So as I mentioned before, posterior prediction is the Bayesian way of doing this. You may have also heard of a technique called parametric bootstrapping, and that's a very similar sort of technique, but it's done in a maximum likelihood framework. So just to orient you to the tutorial before we move on, you'll notice on the left-hand side under data files and scripts, we have a few different files available. Now for the purposes of this tutorial, we're going to focus on posterior prediction per se. So we're not going to worry about MCMC. We're going to assume we've already set up our model and we've run an analysis to fit that model. So if you're interested in the MCMC part of this tutorial as we move forward, you're welcome to look at the MCMC files under scripts here, but we're not going to talk about them directly as part of this tutorial. We're basically going to begin with the two log files that you see under data files. So single normal posterior.log and two normals posterior.log. And we'll get to those in just a minute to understand more about what they contain.